What's up, guys? It's Mr. Brengle, and today we're going to be going over the concept builder from physicsclassroom.com, motion diagrams. And this one's all about velocity and acceleration vectors. It's super helpful. If you can understand this, then you're in good shape for acceleration. So this says a leftward moving car slows down, decreasing its speed by 5 meters per second each second. Okay, so it says select the dot diagram, or what we call motion map, that corresponds to this motion. So we are simply just picking the position of the car, showing how it changes over time. And it says that it's leftward moving and it's decreasing its speed. So this first one over here would indicate constant speed. Okay. The third one over here, if it's moving to the left, it is increasing its speed because the dots are getting further and further apart, right? These dots represent 1 second passing each time. So if this much distance is covered in the first second, and then this much distance is in the last second, well, it has to be moving faster over here than it was over here to cover more distance, right? And so the correct answer is the one in the middle here that actually shows that the object is slowing down because the distance that it's covering is decreasing each second, and therefore it must be moving slower and slower. So that's kind of the thought process for how you'll choose your dot diagram. Now, this is still the same question. It says, now select the velocity vectors that correspond to this motion. So now we're just putting arrows on it, right? So the velocity is always in the direction of movement. So since the object is moving to the left, we need to show arrows pointing to the left. So you can automatically eliminate all arrows pointing to the right. So these two and this one right here. Okay. So now we need to look at the other diagrams. This one shows constant velocity because all the arrows are the same length. So that one's incorrect. This one shows increasing velocity because the arrows are increasing in length. But the last one here shows decreasing length with the arrows, which does indicate that the velocity is decreasing. So we'll choose this one. Okay, and we'll just do a couple examples because all these are going to be the same, and then you can work through the rest of them on your own. So this says a leftward moving car speeds up, increasing its speed by 5 meters per second. So again, the object's moving to left and it's speeding up. So what we're looking for is that the dots are getting further and further apart. That would be this one on the right here. So as the object moves to the left, the dots are getting further and further apart. And then if we were going to predict what sort of velocity vectors we were going to be looking for, we want arrows that are pointed to the left that are increasing in their size because the object is moving faster and faster. And that looks like this one right here. Okay, so we'll do one more here. This one's essentially the same thing that we just did, except now the car is moving to the right. So rightward moving car speeds up, increasing its speed by 5 meters per second. So this obviously changes the motion map we're looking for. We want this one in the middle because it shows that as the object moves to the right, the spacing between the dots gets further and further apart. So it's moving faster. And then again, we're going to be looking for arrows pointed to the right that are getting larger. So we want this one right here, where these arrows are getting larger. Okay. All right. So that's what you're going to be doing with the motion maps and velocity vectors. So I'm going to go back to the main menu here. You guys can finish that on your own. And I'm going to go ahead and click on the acceleration vectors. So now we're going to be doing the same thing. We're going to be picking a motion map, but instead of velocity vectors, we're going to add acceleration vectors, which is going to be a little bit different. So this says that a leftward moving car slows down, decreasing its speed by 5 meters per second each second. Choosing the motion map is the same idea. We're looking for the dots that show that as the car moves to the left, the spacing is getting smaller and smaller, right? This is showing that the car is slowing down as it moves to the left. So the acceleration vectors are different than the velocity vectors. Velocity is always pointed in the direction that the object is moving. Acceleration vectors are a little bit different. If the object is speeding up, your acceleration vectors will be in the same direction as the velocity or the movement. If the object is slowing down, which is the case here, your acceleration vectors must be in the opposite direction of movement. Since this object is moving to the left, that means that our acceleration vectors must be pointed to the right. And it does say that it is decreasing its speed by 5 meters per second each second. That's indicating a constant acceleration in the rightward direction. So what we're looking for are arrows pointed to the right that are all the same length, which happens to be this first one right here. Okay, so the same length arrows indicate constant acceleration. The object is moving to the left and slowing down, therefore its acceleration must be to the right. Kind of think about that like if you wanted to slow down somebody that's pushing a shopping cart, you would have to push against them in the opposite direction to slow them down, right? You would make them accelerate in the opposite direction. If you wanted them to speed up, you would push them in the same direction, which would cause an acceleration in the direction they're already moving, and then they would speed up. Okay, so we'll do a couple examples here. So this one says a rightward moving car slows down, decreasing its speed by 5 meters per second each second. So if it's moving to the right and slowing down, we're going to want this far right dot diagram because this shows the distance is decreasing each second as we move to the right, which is good. And then again, let's reason through this. If the object is moving to the right but slowing down, its acceleration must be to the left. So let's make sure that we eliminate all arrows pointed to the right. So these three right here, we're looking for arrows pointed to the left that are all equal, which would be this one right here, showing constant acceleration in the leftward direction, even though the object is moving to the right. Okay, great. This will be our last one. You can do the rest on your own. This says a bicycle is moving with a constant rightward velocity. So if it's a constant velocity, obviously the distance covered each second will be equal. So we'll choose this dot diagram. And then for acceleration, if an object, remember the definition of acceleration is change in velocity over some period of time. And if the object has a constant velocity, it is not changing its velocity, therefore there is no acceleration, and we would pick this one here. We didn't have an example like this where we went over the velocity vectors, but for this one, if you were choosing velocity vectors, you would be looking for arrows that are all the same length pointed to the right. Okay, so we'll go ahead and go back to the main menu now that we've done a few examples there, and we'll go ahead and move on to this last trophy. And this is the motion diagram challenge. So it's going to have you do all three things here. I'm just going to go ahead and click through this here. So this says a skateboarder is moving rightward with constant speed. Constant speed indicates same distance covered each second. So we'll choose this dot diagram. Since he's moving to the right with constant speed, we want to choose a velocity vector that shows that the velocity does not change, and all these are equal, and it's pointed to the right. And then for the acceleration, since it's constant velocity, we're going to have no acceleration. The velocity must be changing for there to be an acceleration. Go ahead and check the diagram, and we are good to go. So unfortunately, we got another constant speed one, so I'll go through this quickly. And this one's just to the left, so I'm choosing constant velocity to the left, and then no acceleration. Okay, now this one says a rightward moving speedboat slows down, decreasing its speed by 2 meters per second each second. So it's moving to the right and slowing down, so we're going to want this dot diagram here that shows the object covering less and less distance each second. Since it's moving to the right, our velocity vectors must be pointed to the right, but the arrows should be getting smaller, like this one here. So this is indicating that our velocity is decreasing each second. And now for acceleration vectors, since the object is slowing down, our acceleration must be in the opposite direction from the velocity or the movement. And it does indicate constant acceleration. It says it slows down by 2 meters per second each second. So we're looking for leftward pointed arrows that are all the same length, which looks like these right here. Okay. All right, we will do one more. This one is another slowing down. Actually, we've done 3 of the 6, so I'll let you finish the rest of them on your own there. If you have any questions, make sure to let me know. Just make sure to go step by step, dot diagram, velocity vectors, acceleration vectors. Think through whether it's speeding up or slowing down and what that means about the acceleration. Again, if you have any questions, make sure to let me know.